inequalities. So without getting too political, this is not about equal rights and stuff like that. This is mathematical inequalities. So maths inequalities look like this. You've probably seen them before. Okay, so what do each of these symbols mean? So this one means greater than. And we can use that, so the way I remember that is because it's got the big part here. So for example, I could say that 4, inequality sign greater than 3, so 4 is bigger than 3, and the way to remember that is because it's got the big gap, that means it's bigger than. Then we have the opposite, less than. So as you can see, it's got the small side, so I could say that -1 is less than 10. So that's saying that the -1 is smaller than 10 because it's got the small side. Or you can look at it the other way and say 10 is greater than -1 because it's got the big gap. So what are these ones with an extra line then? What's that about? Okay, so this one means greater than or equal to. So it's a bit like greater than, but it can also be equal to. So I could also say that 4 is greater than or equal to 4 because 4 is equal to 4. Or the less than, you can have less than or equal to, so I could say that 3 is less than or equal to 3, but I could also say that 3 is less than or equal to 10, because it is less than 10 or equal to 10, because it's not equal to 10, but it's less than 10. Okay, so big side means greater than, small side means less than, this line means equal to. Let's look at some examples. Okay, so example number 1. Okay, so example number 1 looks very short. So x is less than 2. So I want you to draw a number line and then mark where x is less than 2. So the way this works is, here is my number line. I'm going to put 0. Okay, so there's my wonky number line, and I want the values x are less than 2. So let's find 2 on the number line, which is here. And to show that it's less than and not equal to, you draw a circle, but you don't fill it in. So that means you can't actually take the value 2, but you can take, and then, because it's less than, we want to go this way, and you draw an arrow. So that's representing, so all the values x could take where x is less than 2. An important thing to note is the circle is empty if x is less than 2. If I did this, if I said it was less than or equal to 2, that is when you fill the circle in. So that's the notation they use, so we'll do a couple of those and then move on to exam questions. Okay, so next example, x is greater or equal to 5. So I want you to mark that on the number line. So I would find 5, and then I would look at the inequality symbol is or equal to. So I know that I can draw a full circle to show that it can also be 5. And then greater than or equal to means I'm going to take all the values this way, bigger than or equal to 5. Okay, let's go for another one. So first of all, let's just do it part by part. So first of all, let's deal with x is, and we know it's bigger than because it's on the big open side of the thing. So x bigger than 2, I find 2. I'm going to do a different colour because it's a different example. I'll colour code them. So for x to be on the bigger side of 2, I find 2. And I know it's going to be all the values this way. And I do an open circle because I check the inequality and it doesn't have an equal to sign. So circle is open. It can't actually be 2, but it's bigger than 2. Let's do part 2, so cover up that bit. X is, and it's less than or equal to because it's on the small side, less than or equal to 4. So I find 4, I draw a circle, but I know I can fill it in because it can also be 4. Because it's got that equal to sign, and I take all the values this way. Okay, but obviously I'm being stopped by this one, so I can get rid of the arrows and just join these two circles up. And that's that one. So let's do another example. Okay, so for this one, doing in green, this is saying that, so in English this is saying that x, and then it's on the small side, is less than, and then minus 1. So let's go to minus 1 on our number line. Let's draw a circle. We can't fill it in because it's not all equal to, so it can't actually take the value minus 1. So we leave it empty, and it's less than, so we're going to go this way, all the numbers smaller. So when solving equations with inequalities, you treat the inequality exactly like an equal sign unless you multiply or divide by a negative number, in which you flip the way the sign works. So I'm just going to write that down, and then we're going to do an example and see it in practice. Okay, so I've written it out again, I'm just going to say it again just to reinforce the point. So inequality signs in equations can be treated like equal signs unless you multiply or divide by a negative number in which you flip the sign. So, for example, it's always easier to see it. So if I have, so 5y plus 10 is less than or equal to 20. And following this rule, so inequality signs, these things, in equations can be treated just like equal signs unless you multiply or divide by a negative number, in which case you flip the sign. So let's see if we actually have to do that. So I'm trying to solve to find y, so solve. So I want the one that's saying I've got this annoying 10, so if I take the 10 over the other side, I do the inverse operation just as I would with an equal sign, so we're going to treat it the same as the equal sign. So if it's plus 10 on this side, I do negative 10 on this side, leave this the same. So 20 minus 10 is 10. Then my next step is y, and then if it's multiplied by 5 on this side, and I want to move the 5 over here, I do the inverse operation, so I do the opposite, so I divide by 5 on this side, and I'm not dividing or multiplying by a negative number, so this stays exactly the same, treat it like an equal sign, 10 divided by 5, in that case y is less than or equal to 2. Okay, so that's just an example. You'd get the same answer, do exactly the same thing if you had an equal sign there. Okay, what about this one? So this is an inequality because it's got that sign there. So I want to solve minus 3 minus 2y is greater than or equal to 17. So I'm going to treat it exactly like an equal sign, but in the back of my head I've got this thing that if I multiply or divide by a negative number, then I have to change the sign. So first of all, I want y, so I leave that there. I'm going to take this 3 over, so if it's minus 3 on this side, it means I add 3 on this side. Leave this the same because I didn't multiply or divide by a negative number. So 17 plus 3 is 20. Okay, cool. Now we've got y, and then I've got a minus 2 here. So if it's multiply on this side, I want to do the inverse to get it over to the other side. So to get here on the other side, I want to divide by minus 2. Now this is when your alarm bells go off, because it says unless you multiply or divide by a negative number, and we're dividing by minus 2, in which case you flip the sign. So I can just divide by minus 2 as I normally would. So I'm going to have 20 divided by minus 2, but I have to flip this sign. So instead of greater than or equal to, I get less than or equal to. So this is the catch of inequalities. So y is less than, and then I just carry this out. So 20 divided by minus 2 is minus 10. So you saw an example. The first example was when it didn't change anything because we didn't multiply or divide by a negative number. And then this second example shows you what happens if you do multiply or divide by a negative number. So now we're going to move on to some exam questions. Okay, so exam question number 1, part A. Show x is, and then let's look at, think of this in English. X is on the open big side, so this is saying x is greater than 3 than minus 3 on the number line. So first thing to do, draw a number line. Okay, so now we need to show it on the number line. So just as we practiced before, x is greater than -3. Go to -3, draw a circle. Look at the inequality to see if we should fill it in or not, and we shouldn't because it doesn't have the or equal to line, so we leave it empty. And greater than, so we know we're going all the values this way. So that's how we do that one. Part B. Solve 7y minus 34 is, and then this is the small side, is less than or equal to 8. So again, just like we practiced, just start with ignoring it and just do some algebra and just be careful for that one rule. So what I want to do is I want to take I want the y, so I want to take 34 over this side. So to take the 34 over, I do the inverse operation. So I'm going to leave the equivalent less than or equal to sign and do 8 instead of minus 34 plus 34, which is going to be 42. Okay, and now y, and then we want y on its own, so we've got 7 in the way, so we want to take the 7 over, and it's multiplied on this side, so we do the inverse, so we divide on the other side, so we do 42 divided by 7. And the equality sign doesn't change because we're not dividing by a negative or multiplying by a negative number. So that, you just treat it like an equal sign, so that one was absolutely fine. Didn't multiply or divide by negative signs, we just keep it the same way, and then 42 divided by 7 is 6, so y is less than or equal to 6. Part C, write down the values that satisfy this. So I'm going to draw this out on a number line just because I think it will help. Okay, so if I look at this, so first I'm going to look at this part, so I want x is on the biggest side, bigger or equal to -2, so I go to -2, I can fill it in because it's or equal to, and I know it's bigger than, so I know it's going to take the values this way. Okay, now I move on to doing this half, so I know that x is on the small side, less than 3. So I go to 3, draw a circle, I can't fill it in because it isn't equal to 3, and then it's less than, so I know it's going this way. Okay, so I know it is, I can get rid of the arrows, I know it's just that there. But it didn't ask me that, it said write down the values that satisfy, so now I need to look at this and read off the values that satisfies. So from -2, I can write it down because it's a filled in circle, so it can take the value -2. It can be on -1, 0, 1, 2, and then this is one you've got to be careful of. It cannot be 3. It cannot be 3 because 3 is a kind of a donut, so we can't include it. You can't actually take the value 3. So that's that question. Let's do another one. Okay, so last example, A. N is an integer, so that means it's a whole number, so a number on a number line. And then we've got this inequality, -1 is less than or equal to n, which is less than 4. List all the possible values of n. So the way to do this again is to draw a number line. Okay, so split it in half because we've got two parts. So n is bigger or equal to -1 because it's on the big side. So we go to -1, draw a circle, we can fill it in because it's or equal to, and we know it's bigger than, so we're going this way. This half, n is on the small side, less than 4. Let's go to 4 on our number line. Can we fill it in? No, because it's not or equal to, and we're going this way. So we know n can be these values here. So now we need to list all the possible values. That isn't good enough. So starting here, can it be -1? Yes, it can because the circle is filled in. It can also be 0, or 1, or 2, or 3. Careful here, so can it take 4? No, because the circle is empty. Don't have to draw it out, but, you know, helpful. Part B, draw this on a number line. So this time you definitely do need the number line. Okay, so it's a one with two parts, so we're going to split it up. So first let's look at this. X is on the big side, bigger, greater than -4. So that's what it looks like in maths, but that's what it's saying in English. X is greater than -4. Go to -4, draw a circle. Can we fill it in? No, because it doesn't have the equal to sign. and x is bigger than, so we take the values that are bigger. Okay, so this side, so this is saying in English, x is less than or equal to 3 because it's on the small side. So let's go to 3, draw a circle. Can we fill it in? Yes, because it's all equal to, and we know we're going this way, so we just join those lines up. So there we go, we've drawn it on the number line. Brilliant. So part C, solve 3y minus 2 is greater than 13. So remember, we just treat this exactly the same as an equal sign unless we multiply or divide by a negative number. So we'll see if we have to do that. So first of all, I want solve, so I'm trying to find y. So if I want 3y, I'm going to take this minus 2 over, and it becomes plus 2 over this time, the inequality. So 13 plus 2 is 15. Now I want the y by itself, so I'm going to, it's multiply on this side, this multiplied by 3. I want to get rid of it, so when I go over the inequality sign, I do the inverse operation, which is divide, and it's positive, so we don't have this issue of it being negative, so we just treat it as if this was an equal sign, and we do 15 divided by 3, so y is bigger than 5. So no negative signs to worry about there, so that was literally exactly the same. You would solve that exact same way if it was an equals, but you've just got this funny symbol instead. So they're quite nice questions.